Hey everybody, my name is Tovio, and this is another Galvanize Data Science Prep Study Hall. Today we're going to do something, it's going to be like any study hall really, but we're going to do something slightly different where about halfway through I'm going to pivot and we're going to look at note-taking strategies for the DSI itself. And yeah, that'll be in about an hour. That's primarily to support the pre-course for the DSI. There's a number of students who are in there now, and there were some requests about, how in this really fast-paced program, how do you stay up with notes? How do you keep notes? I've got some suggestions in that regard, and I'll be sharing those. So I'm going to start off today just jumping into some, kind of simple problems related to, dictionaries, like taking a function, writing a function, and processing it through a dictionary and analyzing it, which, looks a lot like the technical interview. I'll be doing problems that are easier than what we would see on the technical interview, at least for today. And if you, as always, if you have any questions, if you're stuck on any challenges in Learn, go ahead and ask in the Slack thread that's in the DS Basic Prep, and I can, I'll finish up what I'm working on and I'll jump over to that. Really your questions are why we're here, and everything else that I'm doing is sort of filler, not filler, but is relevant and everything like that. But this time is really for you to ask questions and get assistance with, direct assistance with challenges on our platform. Okay, so why don't we start off with something kind of straightforward, something kind of easy. Go ahead and run this first. Cool. All right, so I'm going to code in here. This is VS Code. I've got a terminal down here. And I might open up some things here every once in a while, but like in Google. And if you ask me a question from a Learn challenge, I'll open it up over here and we'll look through it, walk through it, and do all that kind of stuff. All right, so let's approach dictionaries through kind of a simple-ish paradigm, and I'll give us a little more space. And sorry, I'm just trying to make sure that I'm aware if YouTube ends our stream, which has been happening. We've been having some intermittent issues with it, but hasn't happened yet. So if it does, I might post another link I might post a different link to the same stream. It's not ideal, but it's where we're at right now. It's just the nature of YouTube streaming at the moment. Okay, so I'm going to start just a simple prompt to show an analytic approach using dictionaries. So I'm going to say create functions. I'll just write a generic prompt. I'm not going to put too much thought into it. So create functions that allow you to view the changes in area of a triangle given different base and height inputs. Sorry, I'll let you think about that for a second. I need to answer something on Slack. Okay. Sorry about that. Just letting people know that I'm going to be streaming on some note-taking in about an hour. Okay. So thinking about this, let's first write a function that will give us the area of a triangle. And if you recall, that's 1/2 times base times height. Okay, so easy enough. Let's do area of a triangle, and we'll put in a base, and we'll put in a height. And we'll return 1/2 multiplied by the base by the height. And if we have a triangle of, let's see, if we have a triangle of 5 by 5, right? Let's do 10 by 10. So if we have that, that'll be 50, right? That has an area of 50 square units, whatever that is. So that's pretty straightforward. That's easy. Let's go ahead and sort of analyze how the area changes as we change the base and the height. I'm going to take a really simple approach to this. First, I'm going to make this thing. It's going to this function is going to return a dictionary where the keys are tuples of the base and the height, and the values are the area resulting. So we'll make a maximum base of 10, and I'm just going to start at 1 and go up to a base of 10, and I'm going to do the same thing for the height. So base max is 10, and the height max is 10. And first thing, I'm going to make a dictionary, and then I'm going to populate this dictionary. So for each base in the range from 1 to the base max, and I'm going to do base max plus 1 to be inclusive. I think just semantically, that's what I would want. I would want to include 10. And then I'm going to say for height in range, 1 to the height max plus 1. Okay. So what I mentioned is that I'm going to use a tuple for my keys. The reason I'm going to do this is that tuples are immutable, and I think of tuples as existing for a few different reasons. One of my favorite ways to use them is as keys in dictionaries, right? When I want to have the key actually hold some combination or permutation of something. And this is easy enough to do. First, I'll make the key tuple. I don't have to do this as a separate operation, but I am going to. And then I will take this key tup, right? And that is the key I'm defining. And the area of the triangle that will be the value, I can just snag this as a function call and do that. So easy enough, right? That's all that is. And I'll return the dictionary, and I'll go ahead and call this. So the way that I'm going to call this, I'm going to populate a dictionary outside the function, and even though I could call this D, I'm going to call it D underscore just to keep it obvious that this is a different dictionary. I think it can be confusing for some people when there's a namespace inside of a function and that same namespace is outside the function, whereas D and D underscore are very obviously different dictionaries. So our function is going to return a dictionary, and I'm going to just use the default arguments. So I'm going to go up to base and height of 10. And I'm going to say for each key and value in the dictionary, items. I'm going to initially, and I'm going to play around with this a little bit. Initially, I'm going to say, I'm just going to print the key and the value. So here's the base and height measurements, and then the area is the value right there. So I'll go ahead and run this, and find out that I have an error. And here we go. So now we can look at this, right? We can look at this and watch how our area changes as we change the base and the height, right? So we can see a linear growth, fairly straightforward. I mean, this is pretty accessible math. 1/2 base times height here. We've got 0.5, 1.0, 1.5, 2.0, 2.5, right? Pretty easy to follow series. And then when we change to a base of 2 and we modify the height, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And base of 3 and modify the height, we can see that, again, we've got this doubling process, right? In this case, it's not doubling, it's just increasing by 1.5, excuse me. So 1.5, 3, 4.5, 6, 7 and then when we get down to a base of 10 and we increase this, okay, we get 10, we increase by 5 every time. So that's nice. We can view it that way, and that is, that is, we can think about it, we can pick it apart. We can write this in a different way to get a more visual sense of things. And maybe the way I'll do that is by drawing some lines, right? And I'm not going to do this in a fancy way. I'm just going to do everything in the terminal. So I'm going to make a couple blank lines, and I'm going to say, well, let's consider the area first, and the area is going to be just the value. And then I'm going to print a top bar line, just a top line, where I'm going to take the base measurement and multiply it, so repeat it with a string of just a space and an underscore. And this is just to get some kind of relative, relative visualization. It's nothing, nothing too wild happening here. So I'll do that, and then I'm going to put the base measurement, which is also k sub 0. And then I'm going to print a vertical line, and I'm going to do this with the pipe, right? It's a shift backslash above the enter key generally, and I'm going to do that k sub 1 times, right? And so do that, and then I'm going to print just this vertical bar. And at the end of doing that, I'll go ahead and print the height, just so I can look at it in context of this visualization. So I think that's what I want to do, and let's look what we get. Okay. Yeah. Okay. And so I'm not getting the diagonal line, obviously. That would be harder to do given what we have here. But we can get this sort of general, just some kind of like terminal visualization. Sometimes this sort of thing is convenient and helpful, right? So, right, there's our hypotenuse, and yeah, our area, our base, and our height, right? So this is just a simple approach that we can use to analyze how the area changes as the base and the height change. So let's do a few more things like this. Let's see. Let me check something. Okay. Yeah, so let's do a couple more things like this. So I'll copy this prompt and yeah, and I'll do this on another line. Why not? And I'm gonna probably reuse a lot of code as we go, just to demonstrate that this is easy and pretty straightforward. That we are going to copy this process and apply it in different situations. So instead of getting the area, let's calculate the hypotenuse and say create functions that allow you to view the changes in the length of a hypotenuse. Given different base and height inputs. Okay, so if you don't remember this, the hypotenuse is, it's essentially, we can think of it as c squared equals a squared plus b squared, or a more helpful way to think about this is c equals the square root of a squared plus b squared. Okay, we can call this hypotenuse, base, and height. And I'll just replace these. And just like that, since we have the idea here, well, def hypotenuse, we're going to pass in a base and a height, and we're going to return this thing that I've got here. Notice there is no actual square root function in Python without importing something. So I think I'm going to go ahead and import something. I'll say from math import sqrt, and that'll allow us to use sqrt right here. I could also, instead of using sqrt, I could raise this whole thing to the 1/2. I could do that. It turns out that the square root function is just a little bit better. I think it's just a little bit more performant. So let's go ahead and test this. Print hypotenuse of well, let's just do a right triangle with 5 and base 5 and height 5, and see what that gets. Okay, so this is what I'm seeing as a result for that. 7.07. That sounds about right. You know, it's square root of 50. Yeah, that seems okay. Yeah, where to go from here? The thing we can do, we can essentially use this same function, this triangle area dictionary. I'm going to copy all of this code, but then I think I'm going to pivot a little bit and change this up just slightly. So instead of triangle area dictionary, let's call this triangle hypotenuse dictionary. We're still going to do the base, the height, and build the key tup. But instead of getting the area of the triangle, let's get the length of the hypotenuse. I just need to swap that in there. We can change this triangle hypotenuse dictionary. And the first thing we can look at is this. We can look at this dictionary and look at changes in the hypotenuse as we change the base and height magnitudes. Okay, so we can just see we can just look through this. We can see how this grows, right? So I think what we can think of as being interesting here is holding one value constant, let's say the base constant, and changing, incrementing this height, we can see a certain rate of growth, right? And, you know, it's interesting. It can be interesting. It's something that we can try to explain. Let me say it like that. And then we can compare it to, you know, holding the base at 2. And we can see what that results in, right? So we can just see how this grows. And you know, notice this rate of change. Not going to dig too far into it. Instead, I want to, maybe we can pivot this a little bit and change our, I'll change this print statement first. And then let's look at some other simple problems like this. And we'll just work on these kinds of simple problems for the next bit of time. And kind of go from there. And again, if you have any questions about this or on anything in Learn, go ahead and post them in the Slack thread. Okay. All right, so for key value and dictionary items, instead of area here, we're just going to do hypotenuse, hypotenuse. There we go. That does not look like it's spelled right, but that's okay. So I'm just going to say hypotenuse length, and then everything else I'm just going to leave the same. This visualization, it might not be that helpful, right? Because we can't really print a nice hypotenuse using what we're using right now. But we can take a look at it. And it's sometimes really nice to make some kind of quick visual with any problem that you're trying to solve. So yeah, let's take another, let's just work on another function, right? Using the same paradigm. And I will comment out these print statements. And yeah, let's consider another function. So let's think of area of a square. So create functions that allow you to view the changes in the area of a square when you modify the length of a side. Again, this is just a very simple, very basic analytic approach, and we want you to be familiar with how to do this, right? So you write a function, use a dictionary to maybe look at a range or look at a set of possibilities out of that function, and you analyze the outcomes. Okay, so let's do square area, and we'll pass in a side, and we'll just return the side squared. So this is an even more basic problem than the last problem, but yeah, we're going to solve it in much the same way. I'm going to copy this. Let's see. I'll call this square area dictionary. So def square area dictionary, and all we need to do is pass in a max side length, and I'm going to set this to 10. Why not? And we'll assume that we're starting at 0. Sorry, at 1. So let's go ahead and make a dictionary and say for side in range, and we'll start at 1 and go to the max side length plus 1. We'll assume we're inclusive, like I said. You're not always going to assume you're being inclusive, just to be clear, but I'm being inclusive here. And I'm going to say d sub side is going to get the square's area of that side. And we can just return the dictionary. So I can go ahead and do the same thing that we did before. For key value in d.items, I need to get d out of here. That's the, I don't have that as yet. So I'll just get that by calling the function. This is going to get the square area dictionary. With a, we'll just use the default here, the max side length of 10. Let's do 20. Just get a slightly larger dictionary. And we'll print, and this is that common form, the f string of the key and the dictionary. Sorry, the key and the value. Okay, that looks good. Let's go ahead and run this. So notice that we're just squaring a number, but this does give us a look into how the area changes as we square it. If we want to adapt this for the, to print the sides, we can, but I think this is pretty straightforward. Let's change this a little bit. Again, we're just doing similarly styled problems. So this time, instead of doing a square, let's create functions that allow you to view the changes in the area of a rectangle as you modify the lengths of the sides. Right? Easy. So area of a rectangle is just base times height. So let's do def rectangle area, and we'll pass in a base, we'll pass in a height, and we'll just return those multiplied by each other, base times height. Well, return base times height. To write the dictionary, to analyze this, call this rectangle area dictionary, and we're going to pass in the base and the height. Okay. Easy. And we'll, just continue with this idea. We initialize the dictionary. We say for whatever, this should be max base or base max. I'll do base max. I usually like that a little bit more. Doesn't matter, it's just a name. And then we'll do height max. We'll also set that to 10. And for whatever in, actually, let's do, for base in range, base max plus 1. And then for height in range, base height plus 1. And we're going to go back to that same tuple paradigm. So here's the key is going to be the base and the height. Okay, and then d sub key tup is just going to get the area of that rectangle, right? So rectangle area of the base and the height. And we can return the dictionary. So, this is all pretty straightforward. Notice we're just going to kind of do what we already did. This, I'm going to start copying things, and let's just see. We're just going to knock out more and more of these, right? So D is going to get the the rectangle area dictionary this time. And I'll do a max side length. Let me go grab these, the base max and height max. I'll use the defaults. And easy enough, for key value in the items of that dictionary, we're going to print the key, colon, the value. And base height is not defined. Oh. In range, height max. Okay, for height and range, height max, key tup gets, yep, okay, this looks like it should work now. And we can see how the area changes. Oh, I'm using a height of 0 here. I actually want to go from 1 to the max on both of those. I could look at, you know, I guess it could be interesting, a 0 area, but we're not worried about that. So we can see how this grows. Right? Not too complex here. It's simple enough in the same way that the triangle area was simple. So there we go. We're just looking at how the area changes as we hold the base constant and modify the height. Okay. Continuing in this same vein, why don't we modify the prompt again? And this time, let's just do perimeter this time instead. So create functions that allow you to view the changes in the perimeter of a rectangle as you modify the lengths of the sides. I'm going to go ahead and copy just all of this. And I'm going to modify it. So starting here, instead of rectangle area, I want rectangle perimeter, right? And instead of base times height, I want 2 times the base plus 2 times the height. And instead of rectangle area dict, I want rectangle perimeter dictionary. And instead of calling out to rectangle area down here, I'm going to call out to rectangle perimeter down here. Okay. This is going to, I think we can just call it as it is. Although we do need to change this to rectangle perimeter. Okay. Let's just make sure this is working how we would expect. 12 plus 2 is 14. If we have a rectangle that is 6 units by 1 unit, the perimeter of it is going to be 14 units, right? Okay. So let's really drive this into the ground, and let's consider another problem. Let's copy this prompt again, and create functions that allow you to view the changes in the area of a circle as you modify the length of the radius, right? So, yeah, area of a circle. We'll write that function, def area of a circle, and we'll pass in a radius. And we will return pi times the radius squared. Now, pi is not defined anywhere, so I'm just going to say from math import pi. Okay, so that's going to get us the radius of a circle. And we can create this other dictionary, this, oh gosh, what was I naming these things? Rectangle perimeter dictionary, circle area dictionary, and we'll pass it. We'll have a radius max, and again we'll start this at 1 and we'll default it to 10. Why not? So define a dictionary, same pattern, and just you want to kind of know this pattern just easily, quick, easy pattern. So I'll say for radius in range, radius max plus 1. And we will go from, oh, I'm sorry. Sort of brain malfunction for a second there. The key is the radius, and the value is the area, right? So area of a circle. So this kind of looks exactly-ish, or, completely like that area of a square, where we've got this single key value, not a tuple in there or something like that. And we're just getting the area and throwing that in there, right? We can return the dictionary. And again, with this, very copy-pastable. You want to get very comfortable, right, with copy-paste. It's going to improve your coding time. Also, you'll have less errors in general if you're doing copy pasting. Also, if you're running your code often, you're going to get less errors. Okay, cool. So for key value and d.items, let's print the key and the value, and we'll get a look at how the radius changes. Sorry, the area of a circle changes as we increase the radius. So this makes sense. Yeah. And notice this this rate of change, right? This is kind of interesting. It has like an upward, sort of exponential increase, which makes sense because we're squaring the radius. Okay. All right. So let's take that prompt yet again. There was a question in the Slack that I want to answer. Can I do an overview of Bayes' theorem and how to implement it with code? Since you're in the premium prep, what I'm going to say for today is I'll cover Bayes' theorem more heavily next week in study hall. And that way you'll also have a lecture on Bayes' theorem in the premium prep prior to us talking about it. I'm going to do a bunch of Bayes' theorem problems. And I could lecture on it right now and do problems, but to be honest, at the moment, we're not heavily covering Bayes in the technical interview. And since we are in premium prep covering discrete distributions and also this analytic process, my inclination is to hold off on Bayes' theorem and then cover it more heavily in study hall after we cover it in lecture, if that makes sense. There's a really intuitive way that I like to teach Bayes. And I don't think we have quite enough time for me to do that in half an hour right now. But thanks. Yeah, I'm definitely down to cover Bayes in a different study hall, though, if you don't mind that. So, or we can meet up one-on-one at some point if you want to go over Bayes in a more direct way. All right, so back to this. Let's take the same idea like we did with the rectangle, and let's change this, create functions that allow you to view the changes in the perimeter of a circle as you modify the length of the radius. And this is another case where all of this same stuff still applies. I've already imported pi. I don't need to import it again. I'll just copy all of this down. And instead of area of a circle, let's do perimeter of a circle. And I'm just going to change this function to a perimeter function, right? Or maybe we should call it circumference. Yeah. So let's call this circumference of a circle. I don't know, that might be redundant, but either way, let's call it circumference of a circle. And this is just going to be 2 times pi times r. So pi times radius times 2. I'm actually going to be so lazy that I do that. You know what? We always say 2 pi r. Why don't I just do that? 2 pi r. Okay, so instead of circle area dict, let's call this circle circumf. I think this is redundant. Let's call this circumference dictionary, and let's call, instead of circumference of a circle, let's just call this circumference. And this is easy for radius in range. D sub radius gets circumference of the radius. And instead of calling out to circle area dictionary, we'll call out to circumference dictionary. And that's all we needed to change, right? That's really it. And so we can see how the rate of change of the circumference, if we wanted to really get granular about this, we could essentially get the difference between circumference of 1 and 0, make another dictionary, and get that difference. Then the circumference between, the rate of change, the change between radius 2 and radius 1, right? 12.5 minus 6.2 or 6.3. And then we could do 18.8 minus 12.6, right? We could build a dictionary off of this if we wanted to further analyze the rate of change. We could even make these keys more, instead of using integers, we could start off at 0.01, 0.02, 0.03, or start off at 0.1, 0.2, 0.3. We could really go in and analyze this rate of change in a more granular way, but I'm being more general. I'm just trying to point out how all of these problems are sort of the same problem, right? And this is the initial kind of skill that you want to build toward the technical interview, is just taking a function, throwing changing values into some dictionary and looking at the outcome. So let's do another one of these. And I can kind of do these all day. Let's take this a step further. Create functions that allow you to view the changes in the area of a sphere. This is, again, just a very simple adaptation of the prior function. So area of a sphere is just a slight modification of the area of a circle. So I'm going to grab all of this again. Make sure I'm not printing anything. And this is 4 pi r squared, right? 4 pi r squared. So this is just 4 times pi r squared. That's got to be right? Sorry. Let's assume that is correct for a moment, and I'll look it up in a second. But I'm almost certain that's it. So instead of circle, so here, honestly, I'm gonna change this one thing and this one thing down here, right? And then I'm gonna change the names of things. And what we're gonna see is, you know, how the area of a sphere changes as we modify the radius. So I'm just kind of copy pasting names at this point. Area of a sphere, sphere, right? And then we've got our output that we'll take a look at. And you know, it shouldn't be too much of a surprise how this grows, right? Oh, sorry, this is surface area of a sphere, isn't it? This should be, yeah, that's me. I should have just looked it up, because I do not do these problems very often. Because shouldn't it be like one? I'm gonna stop guessing. I'm just gonna look it up. Yeah, sorry, this is surface area of a sphere. And I keep calling it area. I should call it volume. I'm sorry. Let me just, as I'm flying through things, I'm just, so sphere volume dictionary, volume of a sphere, this should not be 4, this should be 4/3. That's what it should be. 4/3 times pi times radius cubed. That makes so much more sense. All right, radius, volume of a sphere, radius, return. Okay, so we're gonna call this sphere volume dictionary, and we're going to take a look at the output, unless I have any errors in there. Let me just double check. Perfect, okay. And so we can watch how the volume, not the area, but how the volume of this changes as we modify the radius. Okay. Let's do something a little bit different. I think this pattern, you know, you can imagine we can throw any values, sorry, any phenomenon in here that has these kind of simple to analyze numeric values. Let's think about something a little bit different. Yeah, let's think. Yeah, I have a thought that we can try out here. Okay, so this is going to be a little bit different, but in the same family of analysis, right? So create functions that allow you to view. Let's say allow you to analyze the sum of values, sum of numbers between 0 and 1,000, and let's just say inclusive of 1,000. I'll say inclusive-ish of 1,000. While sum of numbers between 0 and 1,000 that are divisible by n, where n starts at 1 and stops at 1,000. Well, I'll just write this because it's this is easy enough to write. It's sort of hard for me to explain sometimes the thing that I'm thinking, but this is kind of a number theory thing. So if we were to add 1 plus 2 plus 3 plus 4 plus 5 all the way up to 1,000, that's going to be some result. And then if we start at 0 and we go 0 plus 2 plus 4 plus 6 plus 8 all the way up to 1,000, that's going to be a different result. Offhand, it should be less, right? But what we'll end up is a series of numbers, a series of sums that start out at our maximum value, right? The summation of all numbers from 0 to 1,000 to a minimum value, which will be the summation of just 1,000, which is 1,000. So let's do this. I'll just call this summation by steps. Why not? And let's do a max value. Do max value of 1,000, and we'll assume being inclusive here. And we'll make a step value, and by default, why not? Step value will be 1. Okay, so the easy way to do this, or the nice, simple one-liner, would be the sum of the range from 0 to 1,000, 0 to the max value, plus 1, right? And going by the step, right? So I'll return that. And let's print the summation by steps of all numbers from 0 to 1,000. So that's an interesting number. I don't know, it's kind of cool, right? 500,500. It's very, I don't know. It's kind of cool. All right, so let's make a dictionary. So I'll call this, I don't know, summation step dictionary, and we'll go from we'll also set a max value here of 1,000, because what if we want to vary this? What if we want to go up to a different number, right? Instead of the sum from 0 to 1,500 or something like that. So I'll set max value to 1,000, and then I'll set the max step value to, why don't we do to 100? I don't necessarily want to make a dictionary with 1,000 keys right now. I think we'll get more out of analyzing this up to a max step value of 100. Okay, so let's say we've got a dictionary, easy. I'm gonna say for num in, I'll say for step in range, and we'll go to the, we'll go from 1, right? Because, let me call this step value. Yeah, I'll just call it step value. We'll go for step in range from 1 up until the max step value plus 1. And we'll call out to summation by steps. And we're going up to, so we're summing all values from max value. And this step value, I'll just pass step into here. So step value is going to get the step that we're currently at. And I'm going to load this into the dictionary. D sub step is going to get that, right? And we can return the dictionary. So this is a different problem, kind of has a different feel to it, but it's at the end of the day, it's not really different. We've got a function, and we've got sort of this dictionary that we're getting out of it that we can then look at, right? I could have copied code here from the beginning. It would have been different, but it's not so different a problem that we can't do some code copying. So instead of getting the sphere volume, I'm getting the summation. I'm just going to do this with its default values, which I don't need to explicitly put in here. I could just leave it blank, but I usually like, for readability reasons, including the default values. That's really your call. So for key value and d.items, let's take a look at what we get. Okay, so now 500, 500, 250, 250, 166, 833, 1. This is potentially an interesting series of numbers. We get a decline in the rate of change, or sorry, and yeah. So we've got this negative rate of change, and it is declining, right? That number, that rate is getting slower and slower. And when we get up to 100, then we get this this number, right? 5,500. That looks really kind of similar to 500, 500, right? So that's interesting. Why don't we take the step up to I don't know. Let's do 200, or maybe I'll do 150, and see what we get. So right when we're around 100 here, we get 5,500, then we get 4545, right? 4590. There's something interesting happening here, and we can kind of see it. And if we want to really dig into this, of course we can. We could make another dictionary showing the rates of change between these values as they increment, right? Between the step values as they increment. So that's pretty that's pretty easy. Just kind of cool. Let's do something a little different. Yeah, let's do something a little different that uses some randomness. So how about this? So create functions that allow you to randomly sample the lengths and widths of a triangle, okay? And let's build a dictionary where the keys are the resulting areas and the values are the counts of the occurrences of those areas. Or let's do this one better and say, and the values are lists of lists of tuples representing the base and height measurements. And so we'll do this one. We'll do this one, and then I'm going to close the stream and open it back up, and we'll talk about note taking. And that's what we'll do for the next hour after this. Okay, so create functions that allow you to randomly sample the lengths and widths of a triangle. All right, so let's write a function called get random length. How about that? Get random length, and let's do from a min. So I'll call this min length, and we'll set that to 1, and let's pass in a max length, and we'll set that to 10. I'm going to just say I'll do this with random.choice. So from random import choice. I could also do randint. I usually use choice. Randint is probably more appropriate here, but I like random choice. So I'm going to just return a choice from the range from the min length to the max length plus 1. Okay. So that gets us a side, whether it's the width or the height. And then I'm going to snipe this area of a triangle, because that's what I said, right? Area. And the values are the list of tuples representing the, where the keys are the resulting areas and the values are the list of tuples representing the base and height measurements. Okay, cool. So let's say def get area and sides, and we'll again we'll use this min length, max length, min length, max length, and I'm going to do this. So here's the area. So I'm going to just make something called area. And this function is a little bit redundant, but that's okay. I'm just breaking the ideas out. So I'm going to get the base as get rand length of the min length and max length. I'm going to change this just a little bit. I'm going to say the min base length and the max base length. And I'm going to do the same thing for the heights. Okay, this looks like a lot of parameters. It's not that many. You do sort of want to err on the side of, you know, if you have more than 5 parameters that you're defining, you might want to rethink that. I would be more likely to pass this in as a tuple, personally. So that would be kind of nice, just a 1, 10. But maybe I'll do that. So just to demonstrate what I mean, let's do min max base, and let's do by default this is going to be a 1 and a 10, right? So that's my inclination. I think it makes a slightly cleaner thing to look at, and we'll make a min max for the height as well. And I'll just call that HT. So the base is going to get a random length, and notice we're passing in the min length and the max length. This is going to be the min max. We're going to do this twice, and this is going to be that initial value, right, 1, and this is going to be the second value, 10. Okay, so now that we've got that, that's going to just be a random value. We can do the same thing for the height. And I'll do height, and we'll do the, instead of min-max base, we're going to do min-max height. And area is going to be 1/2 times the base times the height. We want to return the area and the base and the height. And since we might as well make this a tuple, the base and the height, because that's how we're going to use it in the dictionary. Cool. So hopefully that works. Let's just run it. You know, there's this thing that happens when you just sit there and code and never run your code. It becomes rife with errors, and of course this has an error because this isn't index 2, it's index 1. Cool. So there's that. So an area of 20. Does that make sense? So 8 times 5 is 40, divided by 2 is 20. So that gives us our area. Perfect. From here, we can just do, what do we want to call this? Rectangle, let's call this triangle area rates. And we're going to, let me make sure I don't forget my prompt up here. I'll just grab that. So def triangle area rates, and we'll do, what do we need from this? We need our min-max base and our min-max height. So we need these values as well. And I'm going to say, I'm going to create a dictionary. And this time we're going to say, oh, we need a number of samples. All right. So a number of samples, and I'll start this off at 1,000. Okay. So we're going to sample for whatever in range, and we'll do a number of samples. And I'm going to say, I'm going to call out to our get area and sides. And this is going to get 3 things. Remember, this is going to get the area and the dims, the dimensions. So I'm going to say area, dims, and we're going to pass in the min-max of the base. Again, we've got defaults here, but I'm calling back to the whatever we can change this if we want. When we call the function, we could pass in different values for the min-max and take a look at what that looks like. So, got a question in here. Where's the link for this session? Let me go ahead and paste the link into the thread just in case that link has changed. Oh, okay. Sorry. That's coming through from the pre-course. Let me just message I'm still working on a study hall problem, and we'll switch to note-taking strategies shortly. Awesome. Okay. So hopefully I didn't miss any questions over here. Cool. All right. So we're getting the area and the dimensions. Remember, the dimensions are a tuple, and that's kind of convenient, right? Create functions that allow you to randomly sample the lengths and widths of a triangle, build a dictionary where the keys are the resulting areas, right? So we've got the area. We're going to get a random triangle dimensions here and the area of that triangle. We can use these immediately. And the values are lists of tuples representing the base and height measurements. Okay, easy enough. We can say if the area, we first have to check for membership. If the area is not in the dictionary, then what we can say is d sub area is going to get an empty list. This is how I do this. I could make the empty list and set the tuple inside of it. I prefer only doing the conditional check, and then in all cases, I'm going to do dArea.append, and I'm going to append those dimensions. So even though this looks like, it looks different from the prior functions, it really isn't. And, when I say that it isn't different, obviously I'm using a sampling approach, but I'm ending up with an analysis at the end. And in that analysis, I'm actually just going to snag this code one more time. And I'm going to say, okay, D gets the, in this case, triangle area rates for 1,000 samples. And I'm going to say for key and value in d.items, I'm going to print the key. But instead of printing the values here, I'm actually going, remember these values are lists, and I'm going to traverse those lists. So for tup in v, I'm going to go ahead and print, and maybe I'll just put a tab in here to give us a little bit of room to play with. And I'm going to print the tuple. So let's see. That worked. Oh, or did it? Yeah, it did. But here's the funny thing. Notice that we don't need all these tuples, do we? We just need, because 7 and 10 and 10 and 7 are going to be interchangeable for us. Really what we need is the lengths of these, except when we get down to here, right? We can see the tuples that lead to an area of 4. An area of 8. If we have two sides of length 4, then we have an area of 8. If we have a side of length A and an 8 and a side of length 2, we get 8. And so there are more possible ways to get an area of 8 than there are some of these other areas, at least when we're, because we're dealing with this range from 1 to 10. It also seems that 9 and 7 come up a lot, possibly. I might be wrong about that. So I'm going to just modify this. We don't necessarily, what's a good way to do this? Let's print, instead of the tuple, let's print the set of the tuple. And that way we're just getting rid of duplicates, right? And I think that'll be fine. So in this case, I'm going to print the key, and I'm going to print the length of v. So I think this will probably be more helpful in our analysis of what's going on here. Name tup is not defined. Of course it's not, because we want to get the set of v, which should get us. So here we've got, it's not that readable. So maybe what I'll do is get this all on one line. I think it'll be a little nicer to look at. And I'm also going to, and I'll say, so possible dimensions, and let's go ahead and add a couple things, couple spaces, and I'm going to sort all of this. And I think that will get us closer to what we want to see. So looking at this, we've got a number of these that have more than a couple of possible dimensions, and a question we might ask is there a correlation between the number of ways to get an area and the count of that area? So that a count of that area occurring, and my suspicion is that is the case, right? So we've got an area of 20, and we can have 4, 10, 8, 5, 10, 4. Really, this is just 2. 4, 10, and 10, 4. We could trim this down even more, right? We could just have, right, 7, 5, and 5, 7. These are really the same. But keep in mind, we could change the dimensions of the height, so that would change our random process somewhat. But notice when we've only got one way to achieve something, like an area of 12.5, there are only 8. There's only an 8 count of that, right? And my suspicion is that we're going to see something similar for like 1, 1, right? It's kind of in that same low count, like 12. Whereas we're in the 40s for things that have more ways random numbers can achieve that area. Okay. Just it's a little bit of insight, and maybe that goes without. Maybe it seems a little bit obvious, but it might not be totally obvious for a lot of types of problems until you break down things into kind of a simple analytic approach. Okay, so what I'm going to do is I'm going to take 3 minutes really quick. I'm going to end the stream, and then I'm going to, well, no, I'm not going to end the stream. I'm going to pause the stream and come back, since we've got a number of people on this stream already, and then let's get into some note-taking strategy. And I'll put a quick announcement in the channel so people... Oh, it looks like Lance already stated that. Cool. All right, I'm going to be back in just a moment. I'm going to put us into a little bit of hibernation for a second. So, I'll see you all in a sec. Okay. So yeah, if you're just jumping on now, it looks like we've got a number of people watching. If you're in pre-course or if you're not in pre-course, kind of what I'm going to talk about is methods of taking notes. Right. This is something I'm gonna teach what I wish somebody, or I'm gonna explain what I wish somebody would have explained to me. I think prior to when I went into the DSI. So, as you all know, the DSI is a lot. There's a lot of material. There isn't necessarily that much time for you to, for you to absorb everything. And what I would argue is don't try to learn everything while the DSI is happening. But make sure you can get to everything while the DSI is happening. So I'm going to walk through just a simple strategy. This may seem overly simple. This may seem overly simple to you, but I'm going to try to explain why I think what I'm going to recommend to you is a good way to go. So I think I made some notes about what I wanted to talk about. All right, so what I'm going to recommend is that you use a single document for note taking, and that may sound wild. Like, why wouldn't you separate your note taking into different documents that are named well, or have the date, or have some kind of good organization scheme? And what I'm going to suggest is that while the DSI is happening, it's going to be difficult to effectively organize your materials in a way that will also allow you for quick information retrieval. So where I'm going to start with this is on GitHub. So I'm just going to go to GitHub, and I'll go to my account. And the first thing I'm going to do is I'm going to make a new repository. And what I'll call this is, for me, I'm going to call this Delmi, and then I'm going to call it master notes. And or maybe I'll call it master DSI notes. It doesn't really matter. Obviously, if you're going to make something like this, you probably don't want to call it Delmi. That's just my key to know that I can just delete this. I have various notes documents, but to this day, I keep all my current notes in a single document. And I hope that I can show you why shortly, and make a justification for this that you'll feel good about. For this kind of document, I generally will make it private. And I can do that because I pay the what I think of as sort of insanely low monthly subscription cost for GitHub. I think it's under $10. It might be around $10. I recommend you do that because there are going to be things that you want to work on that you don't necessarily want just exposed out in the world. But it's really your call, right? You're keeping a notes document. I don't think that your notes document is going to negatively reflect on you, but do keep in mind that in the DSI, there are going to be some things that you are going to be asked not to share, potentially, because either that is some proprietary data, or, well, really it's just that. There might be some proprietary stuff. Whether proprietary to Galvanize or to another party. So, my recommendation is keep your notes private, because you might be linking out to something. I'm going to also initialize this repository with a README, and The idea here is that your README is going to be where everything lives. I'm going to add a git ignore, and I'm going to just set this to Python because you might want to put other things in your notes document. Like you might want to put some, or in your notes repository, you might want to put some Jupyter notebooks in there. And in such a case, you don't want to store all the, what is that? There's a directory of essentially timestamps and instances of your Jupyter notebook. And I would just say, you don't really want that. So I'd throw a git ignore in here as well. So I'm going to create the repository. And from here, what I'll do is I'll just clone this down. So I'm going to copy this. I have a disposable directory called Delmi Sandbox on my machine. I like to have a sandbox somewhere where I can just write stuff that if I were to delete this tomorrow, it wouldn't matter to me. So I'll just do git clone, and I'll pull that whole thing down. That whole one file that's in there, and or one text document, markdown document, and then I'll go in there. Delmi master notes, Delmi, there's a lot of Delmis in here. So Delmi master DSI notes. Once I'm in there, I'm just going to, I'll open this whole thing up. I'll do code dot, and that gives me, in VS Code, that gets me, I should have my git ignore here. And if I look at this, you know, this is just all the types of files that I'm going to block by default. You know, pretty easy. I don't need to worry about that. The only thing I'm going to worry about actually is this README. And this is going to cover, lightly cover some Markdown. I'm not going to get too deeply into Markdown, I guess. But I'm going to show you the basics of what you'll want to use, want to know how to use for taking notes. So I'll just change this to master DSI notes. Or maybe I'll just change it to DSI notes, however I'm going to do that. Let's make some notes. So let me think of just something that will be easy to think about. Probably the place that I would start is with some links, okay? So I'm gonna make something called relevant links. And offhand, I don't remember how this renders using VS Code because I almost never look at the actual render of Markdown. VS Code render Markdown. Control-Shift-V. Maybe it's Command-Shift-V. Yeah, there we go. Perfect. So I'm going to split this to the right. And, oh. Let me just learn how to use VS Code again really fast. Okay, perfect. So what you can see here on the left is how you can see how we write this and then how it renders. Okay, so under relevant links, maybe I'll just track something down. There's on Stack Overflow. I look this up so much that there's an immediate I can find it right away. So it's not that I really need to put this in these notes, but you know, I might as well if I want to click through to it, you know, just offhand. So this is visualizing all these SciPy stats distributions, and there's a big block of code somewhere at the bottom of this, or a link out to there's a link to a Jupyter notebook, and then the code to generate all these. So this is kind of extremely useful, and this is the kind of thing that I would put in my notes document. So under the relevant links. And usually what I would do is something like this. This is how you create, essentially create a link you've got brackets followed by parentheses. The link itself goes in the parentheses, and in the brackets you put some sort of description. So I'm going to call this all the I'll just call it what it says over here, right? Visualizing the SciPy stats distributions. Visualizing SciPy stats. And I'm going to, maybe I'll just follow this, right? I can put these tick marks around SciPy stats, and look how it renders over here. This makes a nice little, it looks like code, right? SciPy stats. And this is a working link if I click on it. So that's a sort of first step. And, you know, if I'm going to view this, maybe I'll view it in the in VS Code. More likely, I'm going to have a tab open in my browser, and I'll view it over there. So to do that, I'm just going to do git add, and I'll add my README, git commit, and with these kinds of note documents, honestly, I'm not going to make good commit messages because it kind of doesn't matter in this case to me. And I'll show you something that might make your commits much faster if you want. So I'm going to do git commit m, and I'm going to do add link. I don't know. I usually do write good commit messages, honestly. And then I'm going to push it. And that's going to be on GitHub. If I go over here and refresh this page, notice I've got something rendered right here. And this is a fairly simple URL. It's a quick URL to get to. I can just bookmark it, and I can grow this document, right? So that's where we're starting. And maybe, I don't know, maybe you want a quick link out to, let's do LaTeX, Stack Overflow LaTeX primer. How about that? This might be it. There is some page. Honestly, I wish I had the link to this in my notes somewhere, because there is a great LaTeX primer. LaTeX. Oh, it's a MathJax primer. That's what it is. MathJax. Yep, here it is. So this is amazing. Something that you're going to find with Jupyter Notebooks is you'll have this ability to embed LaTeX, and it's going to look nice. So this is sort of you're not going to be able to do this in your Markdown except in the render of VS Code potentially, because your Markdown is going to render these sort of like chunks of LaTeX as text, I believe. Unless they've changed that on GitHub. But if you have a Jupyter Notebook, the Jupyter Notebook will allow for the render of these to be essentially images, or rendered as actual usable mathematical characters. Like, this is nice. If you can put this in your notes, that can be super helpful. But I use this reference on Stack Exchange all the time. So I'm just going to add this link in really quick. And yeah, let's see if we can actually render. Well, yeah, I'll just put this in here. I'll also share this link with you guys because I think it's going to be helpful. This is the MathJax basic tutorial and quick reference. Let me just clean that link up a little bit. Yeah, and so notice what it looks like over here. This is nice. And let's continue from here into something else, something completely different. So, oh, I know. let me share with you just a quick bash script, okay? And this is something that I use, and I'll show you how it works for me. In the terminal, I've got something called getattr. Actually, I think it's all one word. I've got getattr, and I've also got something called getwatch. I'll share getattr with you, and message me if you want getwatch. But getattr is going to make a generic time-stamped commit. I do not recommend that you do this for any software project, software dev project, or any collaborative project you're doing with somebody, or even your own project that you're trying to have good commit messages for. I'm recommending that you only do this in special circumstances if you want generic commit messages for, say, a notes document like I'm using here. So all this does is it pulls and it writes a quick commit message, and that looks something like up here, auto updated. This is my message that I wrote in here, but auto updated Monday 24/17. So it's just time stamping the change to README. Again, we've got this being rendered up here. So cool. So this is a relevant links section. The next section that I'm going to make is a topic section. And so what I usually do, what I personally do, is I'll make a sort of a break line. Like this is sort of like an HR tag if you're familiar with, it is an HR tag if you're familiar with HTML. So you can either use HR. I actually prefer using dashed lines because Markdown for me is pretty readable at this point. Obviously, it's more readable here on the right than it is on the left, but I just work in Markdown so much that even some of those, even this kind of stuff, even LaTeX is fairly readable to me at this point. Not as readable as the mathematical formulation, but it is readable when these kinds of things, these markdowns and markups, become more readable as you use them more. So what I do here, I usually give a couple spaces, and notice I've got this single hash right here. The single hash in front of something is the largest render size, right? Relevant links is rendering large right here. 2 hashes will render smaller, right? So I've got this title DSI notes, and I've got this double hash for relevant links. I usually just use this a single hash for anything that looks like the title of a section. So I'm going to start another section here, and I'll call it bash. Let's just call it bash scripting. So if I'm going to be bash scripting, the first thing that I want to figure out is, well, oh yeah, I was going to show you this getattr, getattr function. So I need to access my my bash profile. So where is that? I might do something like this. I might say bash profile location on OS X. Now you might be looking at this and like, that's pretty verbose, and you're not wrong. Maybe what I'll do is instead do something like this, bash profile location on OS X, as a bullet point under bash scripting, so it doesn't take up as much space. Doesn't really matter. It's more about whether or not you can quickly find something in this document. And of course you can, because you can Command F or Control F and search for something, right? And if I'm like bash, well, I'm going to find it right away. Everything that's related to bash. Anyway, that's a little digression, but we're going to come back to that. So the location of this on your Mac is tilde./bash_profile. So this is just informational, and it's something that's easy to forget. So how do you open this file? I'm going to go over here and I'm just gonna actually open this in Vim. So I'll do Vim tilde slash dot bash profile. Oh, whoops. I am in V or I am in Vim. Oh, my Vim on this computer doesn't have nice color coding. Well, that's sad. Okay. Then I'll just open it with VS Code. And later I'll go back and make Vim look a little nicer. Okay, so here's my bash profile. I've got a bunch of stuff in here. I've got, this function getAttr. So the thing I might do in my README is make something that's like, make a bash function, that might be something that I want to be able to reference every now and then. And one really wonderful thing about Markdown is that you can create these little code cells. They're not runnable, but here is a nice render of that getAttr function that will auto add, will pull, add, commit, and push in one little thing. And I can use this as a template, right? I can use this as a template to write other functions. And that's really why I'm putting it here. I'm not necessarily putting it here because I'm going to reference it in any other way. I might just say to myself, ask myself, well, how do I write a bash function? I think I'm going to do that again at some point. Maybe I should put something in here so that I have a template, I have a reference. So I can do that. Here's another really wonderful thing about this. These triple ticks, this gives you this code box, right? I can throw in here bash, and look what happens, right? I get color coding within here, and I get color coding over here in the render of this this text. Now, one thing that you might notice, this forces scrolling, which I don't really like. I'd rather it word wrapped, which I can set it to do in here. But again, I look at this over like in the browser more often than I'll look at it locally. I'll take notes locally, or while I'm working on a project, if I find myself Googling something more than 2 or 3 times, I'm going to take it and just copy the results of that into my README. And you can imagine this is going to get messy at some point, but remember, does it matter if it's messy when you can just Command F? While you're in class or while you're coding something, you can be just in real time adding things to this README file, and it will grow and it'll get unwieldy. But you can always Command F in here or Control F in here and find what you need quickly. So yeah, so this is just bash scripting. Let's do let's do another section. We'll call it we'll just call it Python. Let's call it Python. Let's do comprehensions. So Python, and maybe I'll do a subsection called comprehensions. And let's say I just learned comprehensions. I am very likely to start with code here. And again, you can just do Python next to the triple ticks, and this will give you color coding for Python. Let's say I want to give myself a very simple template for a comprehension. I'm going to do num for num in range, and then just 100, right? So this gives me that basic, this is just going to give me a list of numbers from 0 to 99, but this gives me that basic template for a comprehension. And maybe even further, I can do, I could make a section called functions to remember, right? And these are the kinds of functions that you might need to write more than once, right? And you want to just snag a quick something out of here, right? So Python, and maybe I'll write in his prime function, right? So def is prime, or let me do one that you've all written over and over again. Factorial, right? Factorial of some number is going to be the that product starting at 1, and we'll just do for num in the range to n plus 1, right? And product times gets the num, and we return the product. Now, you all know how to write factorial, but what about the binomial PMF, right? Do you know how to hand code that offhand? No, you'd have to look it up. And this is a good reason. If you know it's something you're going to need to look up periodically, well, throw it into your README. If you know you're going to look it up more than twice, throw it into your README. There's a section we might do called, this is something that you're all going to learn about very soon. You might have a section called cross-validation or machine learning workflow, or and maybe I'll do it like this. Maybe this is data science workflow, although having data science in here is a little bit redundant. It's all going to be data science. So maybe I'll just call this machine learning workflow, and then have a section in here called cross-validation. And in here, I'm probably going to have something detailing a train test split. You're going to be doing so many train test splits that you might as well just have a box of code, right? A box of code that you can snag out of here and paste into your text editor at any point. That's quick. It's quick. You don't need to retype it every time. And there are going to be some things where there are going to be some moments where if you are trying to retype every step of a train test split, you're going to have errors in there, and it's going to be tricky troubleshooting those. It's going to be easier if you have a nice standard approach to cross-validation, and then you modify it as you need to. And at some point, you're going to be doing k-fold cross-validation, right? And you're going to have more robust cross-validation. You're going to have bootstrap in here, right? You're going to have a basic bootstrap approach. And at some point, you're going to have maybe a section for sorting algorithms, right? And you're going to have, you're going to have bubble sort. You're going to have, and you want to have a couple different ways to perform bubble sort. Maybe, the definition, you have like the, hand-coded algorithm here. And then you have also, heads up, you want to usually have a space. You can't predict the render sometimes for GitHub, so you want to have an empty line between anything and these code cells. So you might have a hand-coded version of bubble sort, and then you might have a library called version of bubble sort. Okay. So I'm hoping you all get the idea here. This is this may seem overly simplistic in some ways, but I guarantee you're not going to want to be fishing through 10 different notes documents, and you're not going to be wanting to rely on Google constantly to find things that you don't know what they are exactly. When you're under pressure, when you've got like half an hour to code something that if you were typing straight that whole time, you might get done in 20, 25 minutes. Well, skip the typing, start doing some copy pasting, and have a good notes document, a comprehensive notes document, even if it is sort of clumsily or haphazardly organized. It's going to be better for you, for most of you. I'm not trying to speak for everybody here, but it's going to be better for many of you to have a document like this and to keep adding things into it so that you have a place to find things. Than it will be to try to memorize all these things or try to have them living in Jupyter notebooks all the time, because Jupyter notebooks, you're going to have to spin them up, right? Although I have a caveat to that I'll show in just a second. Okay, so that's the general idea. I'm going to check the Slack in case there are questions. Sorry, I've just been talking this whole way. Oh, I was just about to answer this question. Any way to reference internally on your notes, like a specific related bullet point or table of contents entry? Yes. I don't generally do that, to be honest, because I just Command F or Control F and just cycle through things a lot of the time, but you definitely can. And let's see, I'll just mark down internal reference, internal link, internal reference. It's really easy. I just don't remember how to do it. How to link a named anchor. A heading in this. Okay, so in standard markdown, place an anchor where you want to link to and refer to it on the same page by link. So this is the kind of thing that, you know, maybe somebody should throw in their notes, right? Maybe just under relevant links, and I really don't think this is a bad idea, have something that's just called Markdown, right? And any notes on Markdown. So, you know, this would be called reference links or internal, what do they call these? Anchors, reference links, anchors, reference links, internal reference links. And just paste this in standard markdown, place an anchor, name ABCD where you want to link to and refer to it on the same page by link text, right? So what if we did something up here, and I'll make a table of contents, very brief, and we'll do markdown, and so place an anchor where you want to link to, right? So let's do this. I want to link to markdown, and maybe I'll just call this markdown, or maybe I would randomly generate something. Oh, sorry. Am I getting this wrong? Where you want to link to and refer to it on the same page by, oh yeah, here we go. And then I'll just grab this, throw it up here, markdown, and then hash markdown. And let's see if that works. I still have the name ABCD there, which is not what I want, but okay. So if I click on markdown, oh, you know what? Let me put this up on GitHub. And let's see if this works how I expect it to. Oh. Let me make sure. Oh, I did not save it. That's why. Okay. Try that again. Yeah, just like that. So there's definitely a way to do that. And what I'll do is maybe I'll rename this to Master DSI Notes Example or DSI Notes Example, and make it not private so that y'all have kind of a template to go off of. I don't know why I didn't just do that in the first place. It seems sort of obvious now that I think about it. But but yeah, there's you'll be able to just clone this down, or fork it and clone the fork, and maybe set it to private if you want to, if you are planning on linking to anything that might be proprietary within there. Let me check to see the follow-up on that question. It appears you are suggesting to organize by topic rather than chronologically. Is that right? I personally, I would organize by topic. Now, it is pretty helpful to have a chronology of the DSI while you're in it, because you might be like, well, what did we do last Thursday? And last Thursday will feel like a month ago. So it's kind of nice to be able to say, we did this last Thursday. But so you could go about it. Here's the cool thing. In this format, you could potentially just put the date here, right? You could just say, well, what's the date? And every new we're at the 28th, right? So this could be 2019, right? 2019. Oh my God, it is 2020. How could I forget that, right? 2020, 09, 28. And I could organize my notes in a chronology, and then always continue from where I'm at the bottom. And what that might allow me to do is, I still have Command F, I still have Control F, right? And that's really that's your miracle worker here. It's having a quick way to perform information retrieval. I personally like being topic organized, because what I find is that code tends to get reused a lot. And if I have a section, and if there's, probably the most important section I would recommend that you have, it would be, matplotlib.pyplot visualizations, right? Because every plot that you write from scratch is going to be an accomplishment. And if you write it once, you might want to save yourself the time of needing to write it again and just have that code to snag and adapt. Especially with plotting. I would say with plotting, but also with pandas operations that you will perform regularly. Because I think I probably said this to a number of you in one-on-ones, or if you were in premium prep. People get stuck. The place where I see people get stuck the most is in pandas and in plotting. That's just what I see. And if you have a quick reference that you've built for pandas, everything that you might do in pandas that you need to look up, it's right there. It's not a mystery. You're not going to be tracking down the same thing over and over again, because that is time consuming. So whether you go chronologically, whether you go topic in a topic oriented way, I think those two, that just depends on you. And I like a topic oriented way because of reusable code. But your code is just as reusable if it's in this document anywhere. And as long as there are words nearby it or things that you're doing in it that you can search for. Also, I really like taking chronological notes, but for this I went topic oriented. But yeah, it's tricky. I don't think one is necessarily better than the other. Cool. All right. So I'm trying to think if there was something else specifically that I wanted to talk about with note taking. Yeah, I think I covered most everything that I intended on covering. Oh, I know what I wanted to talk about just briefly. So let's say I want to have well, first let me embed an image. Let's do that. XKCD cross validation. Is that the comic that I'm thinking of? Machine learning. Oh, this works. I don't know. This is your machine learning system. Yep. You pour the data into this big pile of linear algebra, then collect the answers on the other side. What if the answers are wrong? Just stir the pile until they start looking right. Sure. So let me copy the image address and make sure that is rendering. Cool. I'll just put a quick image in this document. Of course, this, maybe what I'll do is put this under Markdown, right, where it would make the most sense. So Markdown, anchors, let's do images. And this is going to be simply, if I remember correctly, I'm pretty sure it's just that. And I'll add some aside text. Oh, yeah, this is it. So here's the render of it over here. That's really nice. And let's see, stir the pile. And I'll push that up, and we'll be able to see that on GitHub. And we do, right? Now, you can't see the actual snippet here that renders this. If I wanted to make that happen, and in this case, that's what I would recommend you do. Take this and just throw this in its own little code cell like this, right? And then you've got a quick reference that you can also see on GitHub. And again, the logic here with having this sync to GitHub is if you're on a different computer, or if you want to share this with somebody, you can add them as a collaborator. It's just a nice place to have, I can go over here, I can Command F, Control F to search within here as well, right? Markdown. And that'll, the actual search navigation within Chrome is pretty good. Within Firefox as well. They're both really good. So, I can look up SciPy and see that that's the only occurrence of SciPy. Okay. There's a question in here. Can VS Code's Jupyter Notebook be used as a README file? Here we wouldn't have to spin up. And the way I would answer that is I don't have an answer to that. I don't actually have an answer to that question because in general, I'll use Jupyter Notebooks. I won't even use Jupyter Lab much, and I will spin up a Jupyter Notebook. I'll just spin up the server really quick and use it directly, and that's probably me being a minor Luddite and not moving into Jupyter Lab or using VS Code's Jupyter extension. But honestly, part of that is I kind of don't like VS Code. Just got to say it. There are a number of other text editors that I prefer, namely Sublime Text and Vim, actually. But I use VS Code primarily right now because that's what that is sort of the most universal text editor that we use. Also, pair coding on it is easy, and that's why I use it. But I don't use Jupyter within it. But on the topic of Jupyter, what I would recommend, and I'll just do this really quickly to give you a sense of what I mean. What I would recommend is that you make a directory for your Jupyter notebooks, and you say, so I'll just make a directory, and I'll call it notebooks, and I'll go into notebooks. Why not? Oh, actually, first I'll make a new tab, and I will run I have this diabolical git function that will sync every minute, and this is the kind of thing that if you do something like this, you don't ever want to tell anybody, because they will find it to be a git. I should call it, instead of git watch, I should call it git abomination. It's really not what you should do. I only do it when I'm teaching, honestly, because I don't want to flip back over to I don't want to flip to the terminal, git add, git commit, good message, git push. I don't want to do that in real time while I'm teaching. So instead I have a function that syncs to GitHub, and I never use this on projects I'm working on. I only use this when I'm teaching, or I'll use this when I'm taking notes, actually, because I don't really ever worry about it. So I'm just going to run that for a second while I kind of demonstrate what I mean by... I would demonstrate what I mean, but I haven't said what I mean yet. I think it's a good idea to use Jupyter notebooks, but use them in a way to link out, right? So, for example, if I wanted to, over here, have a, let's say a derivations, right? A derivations section. In this set of derivations, I would just have a bunch of links to Jupyter notebooks. So derivation of a perceptron, for instance. So this notebook doesn't exist at this point, but I'll make a notebook really quick over here, actually here. So I'll go into my notebooks directory, and I'll run Jupyter Notebook, and I'll make a notebook called, I'll title it derivation of a perceptron. Now I'm not going to fill this in, but I just want to demonstrate. So this is going to sync with GitHub presently, right? I'll go ahead and reload this. Let's see if that did sync up yet. Probably not. Oh, it may have. Okay. So, of course, this doesn't link anywhere because it wouldn't have. Well, I didn't put a link in the first place. But let's see. The notebooks directory hasn't actually synced up yet. So why don't I? Actually, I'll kill the git watch and I'll do just git adder really quick, because that'll be quicker, because there's a timer otherwise. So we've got notebooks, we've got this notebooks directory, I've got this derivation of a perceptron. A very, very nice thing about GitHub is it will render this Jupyter notebook. I'm going to click through to it, and often, it's unfortunate, but often this will actually, this render will actually fail, and you'll have to reload it again. That's a big reason why I don't necessarily recommend using using Jupyter notebooks, but you can save your Jupyter notebooks as HTML, and you could well, you know what, what I'm going to recommend is just technically a little bit convoluted. So what I'll say is just, if you have short Jupyter notebooks, they're more likely to render. And you know, an encapsulated idea like the derivation of a perceptron, you can link to that from your README, right? From your README on your base page. So how I would do that is just have that notebook pushed up, and take the link to the Python notebook, the Jupyter notebook, and put it like this, right? That said, I would do as much as I could within the README itself and link out to other materials as little as possible, right? If you have some supplementary materials like derivation of a perceptron where the LaTeX is going to be important, right? Where you are going to want to write things in a way that is mathematically appropriate as opposed to just Python. Or if you want to have demonstrations of visualizations, right? A bunch of plots or something like that. That might be a use case to link out to a notebook, but I wouldn't rely too heavily on the notebooks. I would rely mostly on the Markdown file. So that said, let me sync this. Oop. Wherever that is, there we go. And now let me reload that again. When I go to derivation of a perceptron, this should take me to the notebook itself. So that's how I would handle Jupyter Notebooks in this kind of note-taking framework. Again, just my suggestion, not necessarily the way to go. But I definitely think having this single README file as your source of truth, as your massive, ever-growing mess that you can search, I think that is the way to go. I really do. And keep in mind, this file can grow to 300,000 lines before VS Code starts crashing out on it. Probably less than that, honestly. But you're likely not going to get to 300,000 lines. And if you do, you can trim it back. You can trim it back or make a second file at that point. Let me see. Okay. Can I demonstrate the getAttr function more closely? If you delete I can in a second. Let me. I'm gonna wrap up very shortly, but yeah, I'm happy to show the getAttr function. I think it can be really helpful for quick commits. Then again, you want to have meaningful commits. So I would say only use getAttr on things that you are working in directly, or modify the function so that it takes a commit message. That's another way to effectively use it. But let me look at your other question first. If you delete repos on the GitHub website, will you have to then manually delete on your local machine? I'm not sure that I understand your question exactly. If you delete repos on the GitHub website, yeah, if you delete it on GitHub, it doesn't automatically delete it from your local machine, if that's the question. That would be, I'm going to show you a dangerous command for bash. So make a bash function. So I would probably make something called basic commands, and so there's something called rm. So what I'll say recursively delete a directory, and that's rm-rf, and then the directory name. So that's how you delete it locally. You'd go to the parent directory and rm-rf directory name, something like that. Sorry, not something like that. That's how you would do it, or one way to do it. So let's take a look at that that getAttr function, and then I'm going to sign off. I'll make this repo public and just play around with it a little bit. Yeah, I'll just make it public, and if there's something else that occurs to me for, I'll just call this DSI notes template, something like that. And I'll throw in the links of this video as well. I'm trying to think if there's something else I should do. But Yeah. All right. So let's look at this function, and let's just talk through it really fast. So in Bash, this is how you define a function. Just function getattr. This should, I know a lot of you are using Z shell, which is fine. Defining functions is, I think, exactly the same. I don't think there's any difference. I just, again, I'm kind of a Luddite with some things. I tend to use Bash a lot more. But I believe everything in Z shell is backward compatible to Bash. So, you know, you should be able to, there should be a document if it's not your Bash profile. I'm almost certain it is Bash profile. I should just look into this or ask Lance about it. You should be able to modify that and create these kinds of Bash functions. Let's see. So function getattr. I'm doing a git pull first, just in case there's something on the remote repo that I don't have locally. Then here's the dangerous thing. I'm adding everything that's in the repo. And then this is getting the current date, right? So the date gets, and this is getting input in the form of date, right? So date is actually a command in Bash. If I just type date, I get the date. And it's parsing it into a day, month, year, and hour, minute, second. As we can see right here, this is just a little parsing snippet that is tied to the date function. And then I'm just doing a git commit, and this is a message I've defined, auto updated, and then dollar. Oh my gosh, I didn't realize this, but this whole line is actually redundant. That's funny. I don't need this at all. I actually trimmed this down. I actually changed this a little bit to the month. Oh, how did I trim this down? I'm looking at this. Well, month, hour, day. Is that really what? I'm gonna have to look at that. But this is actually the only thing that matters here in terms of the message to get. I'm pulling this command from Bash, this date command, and then parsing the date according to this format. And then I'm pushing it. So all this is a definition and a block of code. Excuse me, a block of code that gets executed. Yeah. All right, so we can use VS Code to make, edit MD files. Why are there note-taking apps like Notion? I'm not really familiar with Notion. Notion note-taking. Be nice if there. Well, I guess this is the about. I could just look at this. I've never used Notion, and maybe it's awesome. I don't actually know. If the thing is, you could accomplish what I'm accomplishing with Markdown with any number of other products, and this looks like it could be really cool. The thing that I'm pushing that may not, well, maybe is obvious, maybe is not obvious. The thing I'm pushing is having a single document somewhere that is easily searchable. Command F, Control F, and searching for something and finding it. Being able to instantly copy a chunk of code. This still is funny to me that I have a redundant line in my getattr function. Anyway, just having these things that you can snag as soon as you need them. Whatever your cross-val code is, and whatever your bootstrap code is, whatever plotting functions you have, having them all in one place, I think it's a game changer, to be honest. if you only have one source of truth and you add things as you need them and delete things as you don't need them anymore, then that one source of truth is just going to be a quick response. How do we get LaTeX working without Jupyter? Let me see if I can answer that really quick. VS Code render LaTeX. Maybe there's just a straight MathJax. Because I would recommend using MathJax for this. VS Code Markdown with MathJax. Jekyll. I mean, my assumption is that it's really easy to do this. I'm just not sure because I haven't used VS Code in that way. I did used to use Atom in that way. I think the limitation that I don't like is that I can't just go to my notes directory or my notes repo and see rendered MathJax in here. I'd have to have it in a Jupyter notebook to see it in GitHub. But seeing it here, right, seeing it in the VS Code render, I don't think that's out of the question. Let me just see. I think this might actually... Oh. Okay. Yeah. So let me say this. Let me just do this. So for LaTeX, this will... let me just verify this. Won't render in GitHub, but will in VS Code. So let's say we're doing the sum from, I don't know, 1 to 25. Oh, yeah, 1 to 25. And I probably want to, I'll just say x equals 1 to 25. And then I bet this will work with, yep. Okay. And then, you know, a sub x, right? Or, yeah, that's fine. So, you know, we've got some list A, and then we're summing all the indices from 1 to 25. And of course, mathematically, that would be, it's the first index is the Python index 0. But yeah, so apparently this completely does render, but let's just double check that it doesn't render in GitHub because, you know, times are always changing. It's very possible it does render. Turns out it doesn't, as we can see here. So this isn't, like, to me, this isn't the end of the world, but it just means that if I actually wanted to get the mathematical formulation, I'd have to get it from the VS Code render, which is not too big of a problem. Oh, gosh, we're going past the amount of time that I wanted to allocate today, but there's a thing that I want to recommend called Snappy. And this is for OS 10. So if you've got a Mac, this is really amazing. So I've got just a quick ability to snag like an image of this and move it around and say, you know, this is Sigma. Oh gosh. I can't write quickly with a mouse, but I think you get the idea. That's Sigma. This is start, right? And end is up here or whatever. And so I can write in here and then I can copy it and paste it somewhere, or I can screenshot it directly, just like this, and oh gosh. And then I have to find it. Usually I find it by just opening up my Finder window and going to Recents. And then I can take that and drop it into the directory. The directory that I'm currently working in. So I'm going to do that behind the scenes over here. Sandbox. And then I would, over here, I'd make an images directory. That's normally what I would do. Oh, not an images file. Oops. Remove images and make directory of images. There we go. And I'm going to take that screenshot I just took of this thing, and I dropped it in there. And I'm just going to make another entry for Snappy. I think it's just called Snappy app. And I'll grab the URL for it here if it actually loads. Oh, that's nice. Okay. Let's see. Well, this isn't a good sign for Snappy, but this is the Snappy app. Easily, you know, screenshot regions of your screen. This is for a Mac, and you know, regions of the screen, write on them, save them, etc. And I'll just put a link to the screenshot I just took. I think it's a really inexpensive, I think it's like $6 or something. I'm not plugging it, I don't work for them or anything, but I use it so much that I think it is actually, it's worth it. Doesn't cost next to anything, so. Oh, you know what? Just gonna. Do this, and I'm going to set this image in my images directory, and just as an example. Okay. Good comment here. Ubuntu has its native screenshot app, as well as FlameShot for taking screen snips with annotation. Awesome. I'm just going to say something like this, screenshotting, and I'll do this, and I'll put just a note here that says Ubuntu has its native screenshot app, as well as Flame, yeah, and yeah, I think I only use Snappy because I've been using it for so long. I'm pretty sure there's something better out there in the world. I'm just used to it. Cool. Thanks so much, everybody. I will make this repo public and clean it up just a little bit, probably not much. Yeah, and if you have any suggestions regarding note taking, those kinds of things, this is my approach. This is a recommended approach, but it's obviously not the only approach. I just think it's quick, and you have everything in one place. You can easily search it, and yeah, there's just a lot.